Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called X V star Parity Quads, and it's by Nurgle's Gift. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or 9-cell region. 9-cell region, not 10-cell region. And the 9 cells regions are denoted by the darkened outline around them. Digits must increase from the bulb of the thermometers. There's only one thermometer here, so this must be essentially less than this digit. And that's how thermometers work. We also have, in the entire puzzle, orthogonally adjacent cells cannot sum to 5 or 10. So, orthogonally adjacent just means that the cells share an edge. So, for example, these two are orthogonally adjacent, but these are not. In the puzzle, in the entire grid, you cannot have two cells that share an edge sum up to 5 or 10. And this is pretty standard for Nurgle's Gift's XV puzzles, essentially. So for example, if this were a 3, you could not have a 2 or a 7 here because they would have to have sum up to 5 or 10, and they are orthogonally adjacent, and that's not allowed. So that's that rule. We also have two lines of the same length and same color are connected X lines. So this is actually very common in Nurgle's Gift's XV puzzles. I think they actually all are always in his XV puzzles, but I could be wrong. These connected X lines, which means they are of the same length and same color, are... What does that mean for these? That means these are all the same? That can't be the case. Oh, that's interesting. Huh. That's an interesting twist. Okay, that's the reason why I'm a little confused by this, but I think this actually does make sense. Counting from the bulb, the first cell, I don't know why he did it this way though. Like, I think it would be the same if he did it another way. I'm not really sure why he has the bulbs in these places here. Because this is the same as saying there's a bulb here and there's a bulb here. Or this is the same as saying there's a bulb here and bulb here. I'm not really sure why there's a bulb in this area. It's kind of strange to me. Anyways, counting from the bulb, the first cell of each connected X line sums to 10. The second cell of each line sums to 10, etc., etc. So let's use this as an example. Starting from the bulb, these two digits must add up to 10. These two must add up to 10. These two must add up to 10. And these two must add up to 10. Right? So that's how an example of how connected X lines work. So for example, if this were, say, a 3, this would have to be a 7 to add up to 10 for both of those digits. I don't know why the bulbs are here and here and here and here, right? This is fairly trivial. Well, this is extremely trivial to figure out that these two have to match, these two match, and these two match. But I don't know why he didn't start from here or here. It would be here and here or these two, right? So normally it would be just a line with... This is a little bit weirder, but I can see the potential for this to be an interesting, like, disambiguation problem. But this must match with this. These two... oh, actually, there is... Okay, never mind. There is actually a disambiguation here. So we don't know for this one how to disambiguate this. This could match with this to add up to 10, or this could match with this to add up to 10. Same for these two also. But that's how connected X lines work. And we also have little quads, but these are not your standard variety quads. These are a unique rule set here. The small white circles with a number indicate how many even or odd digits is in the 4 surrounding cells. Well, obviously this says 4, so that means all the digits here are all even or all odd. And this says 4, so that means all the 4 surrounding cells are all even or all odd. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so since these are the same parity, they're all even or they're all odds. Let's mark them so. We're going to mark this as green. We're going to mark this as pink. These add with these digits to add up to these add up with these digits to add up to 10. So these are both green. These add up with these two digits to add up to 10. So these are both pink, right? These two match with these two to add up to 10. They must be the same parity, right? Because anytime you add up anytime you're trying to add two digits to another digit, and you know the parity of the sum is even, you either have two evens or two odds adding up together. Since all of these add up to 10 in these connected X lines, these two are the same parity as these two are the same parity as these two. Same with this. These two are the same parity as these two. Okay. Now the question is, this is either 3 odds here, if this is 4 evens, or if this is 4 odds. So if this is 4 evens, these are 3 odds here, which makes all of these odd. Let's see. This is pink, so this has to be the pink parity also. These are obviously the same parity, but we don't know what parity that is. That means this. Okay, so this. Okay, let's start marking letters. This adds up with this to add up to 10, and this adds up with that to add up to 10. So these are the same digits here. So this is yellow parity also. This has to have at least 2 pink digits here. This is the same parity as this, which is the same parity as that. So these are the same parities. This is the same parity here. These 2 digits add up to 10. And these 2 digits add up to 10. So these are the same digit. Right? So they must add up with that 1 to 10. This is the same digit as one of these two. We're not sure which. Hmm. Okay. So say this green is even. That would mean these are 3 odds. And since these are the same parity, these cannot be odd because we have that would make 6 odds in row. Wait, hold up. No, pink. No, yeah. We're saying green is even. These are all odds, and all the pinks are odds now. So this is all odds. This is odd. These would have to be even then, if that's the case. If this is greens are odds and pinks are evens. Uh, so, okay, if greens are odd, sorry, greens are even, these are 3 odds, which forces orange to essentially be a green. Because that would be 5, that would be 6 odds if we had these be odd. If greens are odd, that means pinks are even. You would have at least 2 pinks here, and you would have 2 pinks and 1 green here. So these could not be pink and even because that would be 5 evens in row 4, and we only have 4 evens per row. So no matter what, the orange is essentially a green cell. So this is always green. These are always green because it's the opposite of pink essentially. Um, one of these is green. We're not sure which. Mm. So this is either 3 pinks or 2 pinks and a green. Say this was all pink. That would mean all of these are pink. Hmm. So then these would all be odd. Um, this cell must add up with this cell to add up to 10, and it must add up with this cell to add up to 10. So these are the same digits here. Hmm. So A must be one of these cells. D must be one of these cells. D is pink. A matches with Z. So this is Z. B's match with C's. Maybe we should make this Y. So one of these is Y. And I guess we'll make this not D, but C. C's match with X to add up to 10. These two match, so This is the third digit here. So this and this adds up to 10, and this adds up to 10. So this will be the D, and we'll have corresponding W. Is that right? A, B, C, D, E, X, Y, W, X, Y, and Z. Yeah. So Y is one of these two. Y is here. Y has to be one of these four. Interesting. So D has to be one of these three here. If this is C, it matches with D here, but that's not allowed because D has to be here, right? No, D matches with W. C matches with X. So if this is C, this is X, which is possible. Okay, so B is not here. B actually could be the same as A. Oh, that's interesting. So if Y is here, that means Y has to be one of these two digits, which means B has to be one of these two digits. But that also means Y cannot be either of these two, so Y, sorry. Right, so B cannot be one of these, so B would have to be here. B obviously could not be either of these, so that would force this to be B if that were the case. Because there would be no other place for B. If this is Y, that doesn't really tell us much. Hmm. Okay. Oh yeah. There are so orthogonally adjacent digits cells cannot sum to 10. Um. B and Y sum to 10. B and Y both have to be here. So they cannot both be here. So one of them has to be along this line. So if B is here, that would force Y to be here. Okay, D and X are different, also for the same reasoning. C and X add up to 10. C cannot be here, C cannot be here, because they add up to 10. So C has to be one of these two. So since C is one of these two, where's C in column 4? It has to be one of those three. But if it's there, if C is here, X also has to be somewhere along there, right? Because C and X add up to 10. C cannot be here. C is not the same as D, because D must be the same as this digit to add up to 10 with W. Therefore, C must be here. C and X add up to 10, so X must be one of these three, and X cannot be here, so X actually has to be here. which means this is C, so this can't be C here. This is pink. This is pink, obviously. Um, hmm. W cannot be here or here, so W is one of these two. If W is, where is W in column 4? Cannot be here. Could be either on this line or this line. So if it's here, its corresponding value that adds up to a same digit, D, would have to be here. But D cannot be here because of the D in the row, right? Because D and W add up to 10, and this must be the same one because they also add up to 10. So this must be W here, which means this cannot be W because W and D cannot be on this blue line anymore. So W has to be here. This is C and X. C is one of these two. C cannot be either of these two because it would have to have a corresponding X to add up to 10 with it. Right? So C and X add up to 10. This is C to add up to 10 with X. C cannot be here. C can't be here because X would have to be here then if that's the case. C can't be next to X because they add up to 10. So it can't be either of these. Where is C? C has to be here. So since C is here, C is also a pink. So this is not pink. Whereas the C has to be here. X cannot be here then. X cannot be here. X can't. Where is X in row 4? Can't be here because it's next to the C and they add up to 10. So X has to be one of these two, which means C must be one of these two. But C cannot be this one because that's C. So this cannot be X. This has to be X here, which matches C here. And these, wait, that doesn't work. We have a contradiction. How do we have a contradiction here? Well, no. Hold up. Okay. Okay, let's just make sure this... Okay, so part of the problem is I think A and Z are getting mixed up. Like, A and Z could be part of X and CW. So that's probably the contradiction that I'm running into. Okay. A and Z add up to 10. It's the same as these two too. So this must be A. That's fine. Because these match. B and Y add up to 10. And this is at the end of the blue line. So this must be B. So these two add up to 10. C and X add up to 10. It's the end of the pink line, and it's on the 2 point of this gray, 4-length gray line. So this must be C then also. D and W add up to 10 because they're at the end of the 4th at the single length there, and at the 3rd here. of the orange, of the 4-length orange line. So this must match here. So C is one of these three. C and X again add up to 10. So C cannot be here, C cannot be here. C cannot be D, so C has to be one of these two digits. Therefore, where is C in column 4? It must be one of these three, which means X has to be one of these three. So this must be X, this must be C. This is pink. This is pink. X has to be one of these three. And C has to match then. So this must... Oh, they could be the same digit. That's right. They don't have to be different. Oh, okay, that's a pretty big... Okay, I think we've shown C and X have to be 5 then, was what I'm showing. So assuming C and X are different, C has to be here. X then has to be on this blue line, this 4-length here. It can't be here, so this is X. This is C. X has to be on this orange line, which means C would then have to be here, right? So then X would be here, C would be here. But the problem is that where is C? C cannot be any of these. C cannot be next to X. So we have a contradiction. C can't be in box 4 at all, unless C and X are the same digit and are 5. So that just shows that we now know that C and X are 5, essentially. So, right, because previously we were like, well, if C and X are different, C can't be here. It's obviously not B, can't be D, because D and X are consecutive. Or sorry, they're adjacent to each other, orthogonally adjacent to each other, and that's not allowed. So C can't be here because of the C in the column. C can't be B because they're different parities. It can't be D because of they're orthogonally adjacent to each other. C can't be orthogonally adjacent to X. So C would have to be one of these two, which means C cannot be any of these. So C would have to be one of these three, which means X has to be one of these three. X again has to be here, so C's there. And since X is here, X has to be one of these three, and C has to match. And we know that these are the same, definitely. So C has to be one of these. So C is forced to be there, X is forced to be there. C eliminates all C's here, and the X forces C not to be here because they can't be orthogonally adjacent because they add up to 10. Therefore, C and X are 5 because of that. Because this was all assuming that... I don't know what I'm doing here. All the C's are 5, and so is the X. So this is a 5 here. Now the 5 does not have to be here, right? This is 5, this is 5, this is 5. So 5 has to be one of these three. 5 cannot be here or on the blue line. So 5 is one of these three. 5 is odd. So the pinks are all odd. So since the pinks are odd, that means the greens are even. Therefore, we know these are all odd here. So these are even, these are odd. That means all of these are odd. 5 has to be one of these. 5 could be here. Hold up. This can't, neither of these could be 5. So none of these could be 5. So 5 in box 4 has to be one of these two cells. If this is 5, obviously this can't be 5. None of the rest of the column can be 5. If this is 5, this has to be 5, and none of the rest of the column is 5. So one of these two digits is a 5. Hmm. We know there's at least one even digit here. But what does that tell us? I'm not sure. So B and Y both have to be here. Um, B cannot be here because if B's here, Y has to be here. So B cannot be here either because it's orthogonally adjacent to Y. So B has to be in one of these four. Oops. Um, this could technically be Y and that could technically be B. It could be here. Hmm. Okay. At least one of these is even. Um, hmm. So one of B or Y is here. So this is 2, 4, 6, 8. But obviously the 2, 4, and the 6 and 8 cannot be orthogonally adjacent to each other. So we have one of the other 2, 4, 6, 8s is here to match. B could be the same as A. It cannot be the same as Z, though. Say B was A, therefore Z would be Y, so this would be the other Y. Then B would have to be one of these two cells. Sorry, no, this was Y. So then Y would be one of the. Okay, so we have a contradiction. So say B was A, essentially. B can never be Z. If B was A, Y has to be Z, right? Because these add up to 10. And if B is the same as A, Y has to be, Z has to be the same as Y. So these would both be Y. This would not be Y. Y would have to be here then, but that would force B to be here also. And that would be a contradiction because B would be A and B would be here. So B, no matter what, then has to be one of these two. So since B is one of these two, Y has to be one of these two. So Y cannot be here. Where is the Y in where is the Y in the middle box? Again, it can't be Z because that would force this to be B. That would force Y to be here, which would force B to be here, and then B would be both here and here, which is not allowed. So B is definitely here, Y is definitely here, which means Y can't be here. Y has to be then here. And this cannot be Y because it's in the same cell same region as B. So then if this were Y, that would be B, and you'd have two B's in the same region. So Y is here, which means B has to be here. B cannot be here, so B has to be one of these three. That's fine. W cannot be here or here, so W has to be, okay, yeah. And then we had this contradiction, I think. So where is W in column 4? If W is here, that means D would have to be one of these three. But D can never be here, so so W has to be one of these two. And D can be one of these three then, correspondingly. W is also could also be here. Just can't be here because it would add up to 10. It cannot be Z because if it's Z, D would have to be A, and those add up to 10, and they're consecutive with each other. They're orthogonally adjacent to each other. What else do we have? What else do we have? If A and Z are even, that's interesting. If A and Z are even, that means in row 5, we only have odd cells left. So this must be odd. This would then have to be 2 odds and 1 even. And that would be all the odds. So these would then be all even, which would force these to be all even. So this would be all odd here. That would force this to be even, but we know these two, B and Y add up to 10, therefore these two must add up to 10. And so we have a contradiction. So we know A and Z cannot be even. A and Z are odd. Okay, that's good to know. A cannot be consecutive. W, no matter what, cannot be Z because then A would batch D, and therefore they would be orthogonally adjacent and add up to 10. So W has to be one of these two. Where is A? A cannot be a blue, it cannot be in this column, and it cannot be orthogonally adjacent to Z, and it's not D, and it's not 5. So A has to be here, which makes this odd. We have 5 odd digits now in box 5. So this must be a W here, which means this can't be W. This can't be D then. These both have to be even. Oops. Okay, so we know Y is one of these two. B is one of these two. Let's match with C. So we'll make this C and X. Therefore, this must be C and this must be X. B has to be one of these. B and C match here also to match X and Y. B has to be one of these three. X is one of these three. B matches with Y again. Y has to be one of these three cells here because Y and X both have to be here. So C has to be one of these three. The matching X has to match on the blue line then. So C cannot be this one. C must be here and it must match X here. So this is even also, and this is even. We have two more evens here, so these are both odd. Which means these are both odd, so they cannot be B. Therefore, this must be B and is even. We have 4 evens in row 5, which means leaves these as odd. One of these is even, one of these is odd. It's C. C cannot be next to X. Orthogonally adjacent to X. So this must be C, which is blue, and this must be a odd digit. Okay. X and Y are here. Z cannot be here or here, so Z has to be one of these two cells. We now have an XYZ triplet, right? Because we have A, D, Z, and W. This must be D, because that's the only remaining digit left. Z cannot be here, Z cannot be here, so Z has to be here. So it's an XYZ here. This is A and D then. So since this is A and D, this must be A corresponds with Z, and D corresponds with W. So this is Z and W here. This digit, okay, so these three digits are 5, D, and A, right? Well, this cannot be 5 or A, so this is D, which means none of these can be D. This becomes a 5A pair here. This is D, this is D, this is 5 or A. This corresponds to an even and is C? Yes. So C is here, which means this can't be C, this is B, this is C. The B corresponds with Y, so this is Y. C corresponds with X, so this is X. C has to be one of these two. Therefore, C is one of these two here. So C's here, C's here. It's a new C, but interestingly enough, it's also one of these three cells in row 9. Rest of these digits are what? We have 5AWZ. And this is 5A. So 5AWZ corresponds with, so this cannot be 5 because neither of these could be 5 to add up to 10. This could be 5. A corresponds with Z, W corresponds with D, Z corresponds with A. But it cannot be A, so this can't be Z. This can't be 5. It could be A, W, or Z. A, W, and Z only matches... A and Z only match with each other. W cannot match with itself, and neither of these could be D, so this cannot be W. Therefore, we have an AZ pair in column 2, which eliminates A and Z in the rest of the column. This can't be 5, A or Z, so this is D or W. This D or W only matches with AWZ, so this must be D here, which makes this a W, so this cannot be W here. The 5 and A only match with 5 and Z, so this can't be D. So this is W, which matches with D. D is here. D has to be one of these two digits. X and Y are both even, so that's an even digit. B cannot be orthogonally adjacent to Y, so this is C, which makes this B. Same with C and X. So this is B, this is C. That means this can't be C, which means this has to be a C here. Where's B in column 2? Can't be here because of the B in the column, or B in the box. Can't be here. Can't be here because they're all different colors, so this is B. And is even. A cannot be next to Z. If A were one of these, it would be next to a Z. So none of these can be A. Because none of those can be A, this has to be A and this has to be Z. Which means this is a 5A pair. That's fine. 5Z pair. 5 cannot be here or here, so 5 has to be here, which means this is 5, this is A. This is then 5, and this is A. W can't be here. W cannot be orthogonally adjacent to D, so this must be W here. We have what? XY, XY. Z. Okay. Remaining digits in column 2 are 5x and w, all of which can be orthogonally adjacent there. 5x and w corresponds to 5. W is with D, so 5D. X is with C. So 5C or D, those are all valid also. This can't be C though. So since this can't be C, this can't be W? No, X. X and C match. D and W match. Rest of column 5. We need a Z. Z cannot be orthogonally adjacent to A, so it can't be here. So Z has to be one of these two, which means this cannot be Z. Therefore, this is a Z and is an odd. This is even. We have, what else? Z, X, and Y. I think those are the only ones left. Which means this is even, since it's X or Y. C has to be one of these. So this is C. C, X, Y, or Z here. Oops. X, Y, or Z. Cannot be Y because it can't be orthogonally adjacent to the B. Z is one of these. This is an XYZ triplet, which leaves this as B, and what's the last one? B and W. So W is one of these two. W is one of these two. This is X or Y, and it's even. And it cannot be X because, again, C and X add up to 10. So this must be Y, which makes this X. Which means X cannot be any of these. This can't be X. This is a YZ pair, which eliminates Y from the rest of the row. This is X, this is Y. That leaves this as D, Z, and X. X cannot be here. D obviously can't be here. This is fine. B cannot be next orthogonally adjacent to Y because they add up to 10. So this must be W, which makes this B. So this is odd. This is even. This has to be Z then, and this is W. This can't be Z. D and Z are both odd, so that's fine. 5 for D. Remaining digits in column 1 are A, D, Y, and Z. Okay. If Z were the middle one here, it would necessarily be next to A, which it cannot be next orthogonally adjacent to. So this can't be Z. Rest of column 5, we have what? B, Y, and B and Y add up to 10. So if either of them are the middle, it would cause problems. B, Y, and W. So W has to be in the middle between them. So this is W. This can't be B or W, so this is Y here, which makes this B, and these are both even. Five or D is odd, so this is odd too. We have in column 6, we have 5, X, and Z. All of them which can be adjacent, so that's fine. This can't be Y anymore. Can't be Y. Does not add a U. Remaining digits in column 7 are C, W, X, and Z. C cannot be here. W cannot be here. Okay, remaining digits in column 8 are 5D, Z, and Y. Any of them could be Y. That's fine. W and D add up to 10, so this can't be D. This has to be A, which makes this D. A corresponds with W, D, and we could have corresponded to that one anyways. D corresponds with W, A corresponds with Z. W means this can't be W, so this is 5, which makes this a 5. So this can't be 5 here, no 5 here, no 5 in these spots, so this must be a 5 here. And is odd. 5 obviously can't be any of these. Oops, can't be any of these. This can't be D. This can't be D. Remaining digits in column 9 are A, B, D, and X. X cannot be in the middle. Well, A can't be here. B can't be here. So B is one of these two. B can't be here. We know where B is. Okay, so B is here, which means that's even. B cannot be orthogonally adjacent to an X. So neither of these can be X. So it's an AD pair, which eliminates A and D in the rest of the column and the box. So this can't be D. This AD pair eliminates D here. So this is X, which is even, which leaves this as an odd. This must be Z, because it can't be X anymore. That makes this D. None of these are Z here. These are both odd, because A and D are both odd. W and X, either of them. Okay. We have, okay, this can't be A. D cannot be here, here, or here. Where's the D in row 2? It has to be here. So this is odd and D. D cannot be next. This is not D here. This can't be D because of the D there. So this is A, which makes this D. A cannot be here. So that leaves A as here, which means this is odd. Let's see. The only place where Y can be, Y cannot be next to B. That's the reason why this is not Y. Y can't be here because of this Y, and Y can't be here because of this Y. Therefore, this is Y here, which makes this Z. But that's A and Z next to each other, so that's a contradiction. Huh. Ooh, I think we messed up somewhere. Dang it. That's bad. Yeah. This can't be Z. So this would have to be Y, but the problem is Y would have to be... Yeah, B and Y. Yeah, this has to be Z, and this is Y, because of this B and A. But the problem is Y can't be here either. Oh, that's bad. How did I contradict myself then here? Maybe I should color them so that's easier to see. Okay, we're gonna have to make different colors then. Ugh. Uh, The 5 is here, 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 here. Okay. Let's restart with keeping the time. So we know these are even. These have to be even. We're gonna mark these as green, I guess. So this must match this. Because we know these have to match. This is Y, Y, B, B. We had A and Z here. So we'll make those yellow, I guess. This was 5. Matching with 5. Not here. 5 here and 5 here. This was D and W. So this, I think this was D and this was W, which matched D here. The 5s are all, I don't know, pink, I guess. I think the 5 had to be here. Yeah, 5 had to be here. Because, yeah. W could not be here, could not be here. Okay, I don't remember this part. Y could not be here. Y had to be one of these. Uh, D was one of these 3. W could only be one of these 4. Y was one of these 2. So B was one of these 2. We had B and C here. And this was X and Y. This was B and C then to match the X and Y. Z could not be here, so Z had to be one of these. Again, like I think this had to be an AZ pair. This was A. So I matched the yellow. This had to be yellow and A, which forced this to be yellow and Z, which meant A had to be here. So that was the corresponding, and this couldn't be Z. So this was the corresponding W here. So that's the blue one, which matched D here. Okay. X and Y were here. Why did W have to be here is the question. Okay, where is C? C cannot be either of these. Actually, where's A? A cannot be here, so A had to be one of these 2. We have C. So this could be what? C, X. It cannot be A. So this was A, C, and X. This is definitely, I guess the other color. We'll make it orange, I guess. Maybe we make it red. Let's make it red. A cannot be either of these. Right, that's the reason why. So A had to be here. And this was A, B, this was W with C and X. Maybe this was where I messed up. I don't know. This still seems possible. Oh, right. Okay, so what is this? This had to be, odd. That's the reason why. So it cannot be C or X. So therefore, it had to be W, which means this is not W. This is C or X. It's red. This is blue. The W must match with the blue here, so that's D. Right. Which means W cannot be here, so D cannot be here. D is one of these. That meant this was A with C and X. This was... What is this? This was 5D, and 5 cannot be on the line, so this can't be 5. 5D and X? Yeah, so this is D or X. D matches with W, so this can't be W, so this has to be X, which makes this a red. This can't be X, this can't be X. This is the corresponding C. It's also red. This cannot be X. This has to be C. This is X, which means X cannot be here. C cannot be matching that, so this is A. This is C. A is yellow. C is red. Corresponding digits here are B, A, B, C, B, W, and Z. This can't be 5 because of the 5 in the column, so this is D. This is 5. That makes this blue. This is pink. What do we have left here? The remaining digits here are X, Y, and Z. And X, Z cannot be next to an A. So this is X or Y. That leaves us as A and D. A and D can only be can only add up to 10 with W and Z, so this cannot be B, which makes this a B and is green. We have yellow and blue here. This is yellow and blue. This has to be B, W, and Y. And B and Y cannot be orthogonally adjacent to each other. So this can't be B or Y because that would force B or Y to be next to each other. Therefore, this is W, this is Y, this is B. These are both green. W is a blue, so this cannot be blue. This is yellow, which means this can't be yellow, so this is blue. This is D, this is A. We have remaining here 5 5xz. This corresponds to C here to add up with the x to add up to 10. So this can't be C, this is B, this is C. The C corresponds with X, the B corresponds with Y. So this is green, C is red, X is red, so this can't be red next to it. This has to be red, this has to be green. And this is B then, this is C. C cannot be here, here, or here, so C has to be here, which makes that red. Where's the B possible in column 2? It has to be here, and is B. Z cannot be next to the A, so orthogonally adjacent, so Z has to be one of these, which means this can't be Z, which means this is Z here. What do we have left? X and Y. WXY. WXY, WXY, and WXY here. This can't be W, this can't be X. Column 2, we have 5 A, B, C, D, W, and X. That corresponds to 5. W is with D, X is with C. Cannot be C, so it's 5 or D, which means this is 5 or W, not X, and it can't be W, so this is 5, this is 5. No 5 here, no 5 here, none of these are 5, therefore this is a 5. And we have all the 5s left. It's all done. So X and Y are blue and green. X and Y is blue and green. WY. No, X and Y is red and green. I don't know. Not blue and green. Red and green. Y is green. W is blue. Remaining digits in row 9. Actually, let's do remaining digits in column 7. We have what? C, X, Y, Z. And C cannot be here, so this is X, Y, Z. This can't be C, so this is X, Y, Z. One of these is C, X, Y, and Z. If X is either of these, it would be consecutive with C, because C cannot be here, C can't be here. So X cannot be either of these. This is not yellow. Remaining digits in row 9 are D, X, Y, Z. X cannot be consecutive with C, so neither of these are X. We have a Y, W pair in row 8, which eliminates Y and W in the rest of the row. Therefore, this is X and is red. Rest of the, this is blue or green. Column 3 has to be C, Y, or Z. So this can't be C because of the C in the row. This is then C, Y, or Z. Z cannot be next to A, orthogonally. Okay, Y or Z is yellow or green. C or Y is red or green. And C, Y, or Z is red, green, or yellow. This is W, Y, or Z. So blue, green, or yellow. We have what's remaining? AD with Y or Z. There's no W. Because we have a WX pair in the column. This can't be Y. This can't be Y. We have an XZ pair, which eliminates X and Z from the rest of row 3. So this can't be X. This is W, which makes this X. W is blue, so blue can't be next to it, so this cannot be D. This can't be Z, so this must be A, which makes this yellow. These can't be A anymore. Z cannot be next to it, so this can't be Z. This is D or Y, which is green or blue. Z is one of these two, so this can never be Z. This has to be D, because that's the only digit remaining. So this is D. This cannot be D here. Where is D in row 9? It has to be here. So this is D and is blue. X and Z are red and yellow. Okay. D and Y are green and blue. DYZ is green, blue, yellow. X is red. So red cannot be next to it, so this can't be red, and therefore can't be C. Where is the possible C? In column 3, it's here. So this can't be C. This can't be C. This is Y or Z. Remaining digits in column 8. We have what? B, W, Y, and Z. B, W, Y, and Z. Z cannot be next to the A. So this is green, blue. It's green or blue. So B and Y cannot both be. B can't be here either. This can't be W. Um, hmm. B and Y are both green, and Z is yellow. Y is green, and Z is yellow. So this is, one of these is green, one of these is yellow. Either way, one of them's yellow, and therefore the rest cannot be yellow. So this can't be yellow here, which makes this an X. This is Z, this is X. So this is not red, this is yellow, this is not yellow, this is red. This X means this can't be X. We have a YZ pair in column 7, which eliminates Y and Z the rest of the column. So this must be C and is red. This YZ is yellow or green. XYZ is red, yellow, or green. And this is a lot of things. BWY. It could be B, W, X, Y, and Z. So I think that's pretty much all the colors. W, Y, and Z are blue, yellow, and green. This is one of these is yellow, so this can't be yellow here. It could be green, blue, cannot be red. And it can't be blue because the blue is next to it, so this is green. So since this is green, it's B or Y, right? Can't be blue, can't be red because we have two reds already in the row. Sorry, in the box. Actually, in the row, yeah. We have two yellows in the row. Can't be blue because that would be next to each other. This is green, which means this cannot be green. This has to be yellow, which forces this to be green. So this can't be green here. This can't be green here. This has to be blue, and therefore it's D. This can't be blue, and is not D. So it's a yellow-green pair here. This is yellow, so this can't be yellow here. It must be blue. Which makes this a W, which makes this Z, which makes that W. This is B or Y here. This is B or Y here. Wait, no, this can't be B or Y. This has to be Z. So this is Z, this is Y, this is B, which forces this to be Z. This cannot be green. This is yellow. This can't be yellow anymore and can't be Z. This can't be Z. No W, no W. This is Y, X. This can't be B. We have a contradiction again. Wait, how did I get two Y's here? That's the same problem we're running into, right? Hold up. Okay, so, well, okay, part of the problem is I have the wrong letters. So that's one issue. I don't even know how I got the wrong letters there. Okay, well, let's go back to before we had the wrong letters. Ugh, this is problematic. Okay. Okay. It's, yeah, it's W, I think. Yeah, okay, so this is, yeah, where we messed up. We have what? C, W, X, Z. Okay, so this can't be C or W. This is X or Z. C, W, X, Z. This can't be C. So C is one of these two. This can't be W. C is one of these two. If X were there, it would be orthogonally adjacent to the C, so X cannot be either of these. X and Z are red and yellow. We have a WXZ triplet in row 3, which eliminates W, X, and Z in the rest of the row. That leaves A and D. So this is A and D, this is A and D, which means this is yellow or blue, and this is yellow or blue. X and W are red and blue. So this is red and blue, this is red and blue. X and Z are red and yellow. And this could be then red, yellow, and blue. C and Z are red and yellow. Is that right? CWZ are red, yellow, and blue. Okay. This is D with X, Y, and Z here. So D with X, Y, and Z. X cannot be here. So this is... Here is blue, yellow, and green. Cannot be red. Column 3, we have what? C, X, Y, Z. So this is X, Y, Z here. This is C, X, Y, Z. One of these is yellow. This cannot be Y to be next to the B, because that would be green. C, X, and Z both are, C and X are red, and it cannot be next to a yellow because of the A, so this can't be Z. We have a CXZ triplet in row 2, which leaves the remaining digits as B, D, and Y. So B, D, and Y are here. B cannot be here. B is one of these two, and if Y were next to it, they would basically be orthogonally adjacent. So this cannot be Y. So this is a BD pair, which forces this to be Y. So Y is green. This is a green, I don't know, green blue pair. B and D are both here, so this cannot be D. This must be A, which makes this D. So this can't be yellow. This is blue. No, sorry, this is yellow, which means this can't be yellow. So this is blue. This can't be blue, so this is red and X, which forces this to be Z, which forces that to be W. This is not red. This is not yellow. This is not red or yellow. This is blue. This Z makes this an X, which forces this to be C, which forces this to be Z, which is yellow. This can't be W or Z, so this is C, which is red. This can't be Z, so this is X, which is red. None of these can be X then, because of the X in the row and the box. This can't be X, so this is Y. This is X. This can't be red. This is green. This can't be green. This is red. Y and C and X can't be here. Therefore, this is Z and is yellow. This can't be Z or X, so this is Y, which makes this X. This can't be green. This is a green. This can't be Y, so this is W, which means this is blue. This must be Z and yellow. X means this has to be W and blue. This has to be A and yellow. Okay, I don't know how I messed that up that badly. Okay, this can't be Y. This has to be a Y. So this is green. This can no longer be green. This is blue or yellow here. Blue or yellow here. B cannot be next to the Y. So B has to be here, which forces this to be green. This last digit then is a W and is blue, which means this can't be W. This is Z, which makes this W. This can't be blue. This can't be yellow. This B eliminates B here, so this is D here. This is B. So this is the blue. This can't be blue here. This is green. D eliminates D here, so this is Z. No blue, no yellow. This is D. That leaves this as X and is red, and this is Y and is green. Okay. Oh my god. That was kind of painful just to get to this part. And now we have to figure out. So again, the BY and the CXs are the evens. The AWs and the D AWDZs are odd. So, this is going to be interesting. D is greater than Z. Okay, that's all we have. um, okay, yeah, we have to figure out what lows and highs are next to each. Well, we don't even have lows and highs. We have to know what odds and evens are next to each, orthogonally adjacent to each other. Oh, that's painful. Um, hmm. We have. Okay, what is A orthogonally adjacent to? Okay, so we can remove the coloring. Let's make it odds and evens again. Um. So ugh, these are backwards. At least to what I normally have. Okay, we're gonna make C. We're gonna make this dark. Blue D and W's are red. Pinks are red. A and Z's are red. And everything else is blue. Okay. So, okay. We're going to have to look for all the odd digits, which are next to even digits, that are not 5, obviously. And same with the even digits that are next to odd digits. Okay. So there should be at least 2 pairs which are not orthogonally adjacent to each other. Okay, you're right. So if you're next to all of the other orthogonally adjacent to all of the other letters of the other color, that doesn't include 5, obviously, then that means you're a high digit. Okay, that makes sense. So, A is orthogonally adjacent to Y, C, X, and B. So A is a high digit. Right? A is orthogonally adjacent to Y, C, B, and X. So A is a high digit, Z is the low digit. What is Z not orthogonally adjacent to? Z is orthogonally adjacent to C and X, so it must be with B and Y. So Z is next to Y. So B is the corresponding one that it's not orthogonally adjacent to, which is correct. Z is not orthogonally adjacent to any B's here. So B and Z are 1-4 pair or 2-3 pair. We're not sure which. So we're marking these as Z, and these are all lows. Wait, what the heck happened here? They're all Z's, and we want to mark them as lows. B's we're going to mark them as B's, and they're all lows. Okay. Wait, they're even too, I think. So B has to be even. So B's are even, and Z's are odd. So we move the 2, 4. Okay, so that's there. So that means the corresponding ones are C and X and D and W. Okay. D is next to Y. D is next to X and... Wait, no. It's C and X. Right, we don't care about Y's. Y's, actually, I guess we should just do all Y's are 6 and 8. And all A's are 7 and 9. Okay. So that makes it clear for us. X is next to both D and W. So therefore X is the high digit. So X's are all 6 and 8. C's are all 2 and 4. C. What is C next to? C is next to W. So W is the high digit. And so it's 7 and 9, and D is the low digit, which is 1 and 3. And D is higher than Z. So Z's are all 1. Z's are all 1s. A's then must be all 9s. And A and Z were... B then is the corresponding 4. And Y is the corresponding 6s. That means D's are the corresponding 3s. W's are the corresponding 7s. C's are the corresponding 2s. And then X's are the corresponding 8s. Whew! That was, yeah, well, messing up somewhere which you don't know is kind of painful, so that will make things painful. Very interesting use of the odd and even digits. Sorry, yes, odd and even digits, because I don't think he's attacked this personally in a problem before. Usually it's that you have matching sets, right? So you know a set is either part of 1, 4, or part of 2, 3, or part of 1, 9, or part of 3, 7, or something like that. But usually it's I don't think I've done a puzzle of his that had an even odd split here, which was very interesting. Yeah. And then breaking this in was actually very interesting too, right? Particularly figuring out the 5, that the 5 had to be essentially a 5, was very interesting in itself. And once you had that, it flowed fairly well as long as you didn't make a mistake. But it's really easy to make mistakes on these puzzles because I don't know why, the letters just throw me off a little bit when I try to do those. So anytime you have lettering, it becomes a little bit more hairy for some reason. I don't know. I'm not sure why. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.